Hello everyone, I'm SJBIT, working as Assistant Professor in the Department of PC SJBIT. In this lecture, we'll be discussing about computer organization and architecture.
So addressing modes, so far we discussed many addressing modes earlier. So the next addressing is nothing but the base with the index mode. So the effective address is the sum of the content of registers are specified in the instruction. That is Ri, Rij. The effective address is equal to Ri plus Rj. There is a move R0, R1 is nothing but we supposed to add the content of R0 plus R2 the particular memory location. The content should be moved to the register R0. Similarly, we have to add the content of R1 and R2 which is being stored in the memory. The content of the memory location is getting added and the sum is going to be shifted to R1. So next is the base with the index and offset mode. So the effective address is the sum of the constant x and the content of the register are specified in the instruction. That is x of ri, rj is equal to ei is equal to ri plus rj plus x and move 20 r0 r1 r2. So it is going to add 1000 r1 r2 r0. So next is the relative addressing mode. So the effective address is determined by the index mode using the program counter in the place of the general purpose register Ri. So the branch is greater than 0, that is loop. X of PC is equal to EA is equal to PC plus X, and note that the X is the signed numbers, and this location is computed by specifying it as an offset from the current value of X. Program counter. So the branch target may be either before or after the branch instruction. Offset is given as the sign numbers. Auto increment mode. So the effective address of the operand is the content of the register specified by the instruction. So after accessing the operand, the content of its register are automatically incremented to a point to the next item in the list. That is add R0 plus R1. The increment is 1 for byte-sized operands, and the 2 are 16-bit operand and 4 for 32-bit operand. So this is the addressing mode here. This is the auto increment addressing mode. So here the auto increment is nothing but some n value is being specified. Each time it is getting incremented. So that time the loop instruction is getting executed. That is add n number is getting added, and finally the sum is going to move to 1. So auto decrement mode. So the content of a register specified in the instructions are first automatically decremented, are then used as the effective address of the operand. So add R2 R0, that decrement is by 1 byte size operands, that is 2 are 16-bit operand and 4 for 32-bit operand. So next is the assembly level language. So in assembly level language, so machine instructions are represented by the patterns of zeros and ones. So awkward to deal within the discussing and the preparing programs, we use the symbolic names as move, add, increment, and br. So when writing the program for a specific computer, such as normally replaced by the acronyms called mnemonics, such as move, add, increment, and similarly. So we use the notations R3 to refer the register 3, and location is to refer the memory location. So complete set of symbolic names and rules for their use constitute a programming language, generally referred as the assembly language. So the set of rules using the mnemonics in the specification of complete instruction, the program is called the syntax. So syntax of the language. So program is written in the assembly language. It can be automatically translated into a sequence of machine instructions by a program called the assembler. So assembler program is one of the collection utility program that are part of the system software. So the assembler link any other programs is stored in a sequence of machine instructions in the memory of the computer. A user program is usually entered into a computer through a keyboard and stored either the memory or the magnetic disk. So at this point, the user program is simply a set of lines of alphanumeric characters When the assembler program is executed, it reads the user program and analyzes it and then generates the desired machine language program. So later it contains the patterns of zeros and ones, specifying the instructions that will be executed by the computer. So the user program in the original alphanumeric text, it is called the source program. So the assembly machine language program, it is called the object program. So the assembly language program in given computer may or may not be use the case sensitive. It may not distinguish between the capital or the lowercase letters. So it is in order to improve the reliability of the text. So usually we go for the capital letters. So mnemonic move represents the binary pattern of O code. So OP code for the operation of the instruction. So the assembler transfers the mnemonics into a binary OP code that the computer understands. So OP code mnemonic is followed by at least one blank space character. So then the information that specifies the operand is given. The source operand in the register or not. This information is followed by a specification by the destination operand separated from the source operand by a comma with no intervening banks. So the destination operand in this memory location that has its binary address represented by the sum. Since there are several possible addressing modes for specifying the operand's location, so the assembly language must include which mode is being used. For example, numerical value or the name used by itself, such as sum in the preceding instruction, may use the denote the absolute mode, and the sharp sign usually denotes the immediate operand. So adds the number 5. For example, if you go for add number 5 comma 3, ash 5 comma 3. So the number 5, the contents of the register are 3, and puts the result back to the into the register R3. So the sharp sign is not only way to denote the immediate addressing mode. Some assembly language and intent to addressing modes indicated by in the operand opcode mnemonics. So in this case, a given instruction has different opcode. So mnemonics for the different addressing modes. For example, the previous add instruction may be written as add I 5 comma 3. Suffix I is mnemonic. Add I states the source operand in the given immediate addressing mode. So in the indirect addressing is usually specified by the putting the parenthesis. Indirect addressing, this kind of addressing, it is known as the indirect addressing, putting the parenthesis. So for example, if the number 5 is to be placed in a memory location whose address is held in the register R2. So the desired can be specified as move hash comma R2 and move 5 comma R2. So both are same.